Okay, good afternoon, everybody. Welcome back to another installment of FE modeling. So today, my goal is to go through modeling of a simple truss in both SAP 2000 and in VisualAnalysis. So let me bring that over here to where you guys can see it. Here we go. So this is a rather rudimentary truss. I'll go through the analysis of this in both packages. And so the idea is that we do the modeling of this, then I give you a homework assignment where you model a truss. It's actually the truss from the first homework assignment where you guys went through and did the nodal coordinates and the directional cosines and stuff. So you'll create a model of that in SAP 2000 and VisualAnalysis. Excuse me. And then in our next lecture or two next week, what we'll do is we'll introduce some matrix theory and show you guys how to do an analysis of this truss using matrix operations in Excel. And then one of your next homework assignments will be to do a matrix analysis of the truss from your first assignment in Excel. And so that's kind of how the cadence of the class will go. And then we'll go back and do some more work with the beams and things of that nature. So I suspect that for most of you, this class is going to be at a low level. You could probably figure this all out on your own. But still, just for sake of completeness, we'll go ahead and spend a little bit of time going through this and then take a dive into the deep end of the matrix analysis pool next time. All right, so I've got running in the background here, SAP 2000 and VisualAnalysis. Let's go ahead and run this in SAP 2000 first. My phone is blowing up again. Let me kill my messenger app here so I can get rid of all of the notifications that keep popping up. All right, so this truss has 2 bays. It's what a Warren truss configuration. So if I were setting up a grid, I would set up a grid spacing at 12 feet in the X direction and 16 feet in the Z direction. Or I could use the 2D truss template that comes with SAP 2000. So actually, let me go ahead and do that. And let me do this first. There we go. And we'll start off that way. So new model. We'll use a 2D truss. And so you can go in here, the number of divisions that you want, I think is 2. And the height of the truss is 16 feet. And the division length is 24 feet. All right, and so I can use a custom grid spacing. I usually like to have the lower left node as at X equals 0, Z equals 0. And if you go by default, it'll put the origin of the model in the center, and that's completely unacceptable to me. So here we go with 12, that'll be 24, that'll be 36, and that'll be 48. Now there's something else here that's kind of interesting. When you use this grid data, you can actually specify the ordinates or the absolute values of the grid lines, or you can actually go in and specify a spacing, and the spacing is sometimes more convenient than specifying the ordinates themselves. So that little checkbox or radio button there is handy for that. All right, let's hit OK. I'll just leave the chords and the braces as their default for right now. And you see we get a nice truss. It even has a pin support at the left and a roller support at the right. Which is what we want, right? So, okay. Now, this model is a little bit strange relative to the more realistic or more real life models in that instead of specifying cross sections like a W shape or an HSS shape for the members, I'm just telling you that the area is equal to 8 inches. So what we could do is select a cross section, say an HSS 6x½ for the cross sections. And when we do that, we get a member that has an area that's 8.09 inches squared. We could also go in and use a user-defined section if you wanted to, and we could put in the member properties directly. But I'll go ahead and use that HSS 6x². Since it only has 2 numbers instead of 3 numbers, that means it's around HSS, by the way. That's an indicator. If it had 3 numbers, it would be a rectangular or square HSS. So let's go in here. I'll go to define section properties, frame sections. I'm going to have to load my catalog of shapes. Let's see, this is going to be a tube. And there we go. And so I'll go in and I don't know, maybe I've got the wrong one. It's not a tube. It's a, let's see if I could, is it come up under a pipe maybe? I really don't want to call it a pipe because it's not a pipe, but yep, well, okay. They're calling it a pipe. There we go, HSS 6x1/2. There we go. The material is really not A992 grade 50, but we'll just leave it as such. Excuse me. All right. Then I can go in and I can select all of the members, drag a window, and then go to assign frame sections, and I can assign that property to all of those sections. All right, cool. All right, now let's see, what else do we have here? All right, there's different views, right? Nodes are invisible. All right, so we're going to change the dead load pattern. So let's go here to our loadings. I want a center point load of 22 kips. So let's go to define load patterns, and I could call it a dead load, but I want the self weight multiplier to be 0. So I'm going to go click 0 there, modify that load pattern. Let me actually just call it D as well. Okay, let me go over here into the right window. I'll go set display options, Control W, and I'll make the nodes so that they're visible. There we go. Now we can see the blue boxes for the nodes. I'll click on that node there. I'll go up to assign joint loads, and I'll put a force on that node. And so it'll be D. I'll put it in the minus Z direction, so minus 22 kips. All right, so we get that load like that. Excuse me, there we go. Let me mute my microphone for a second. I've got a scratch in my throat. Sorry about that. Okay, I'll go ahead and save the model now. It's going to ask me to save it before I run it anyways. So let me go in here. I'll go to my temporary directory that I use. I'll call it, I should just create a directory for in-class models. Let me call it, I'll call it truss in class like that. There we go. Thank you. And then I'll call it truss in class. All right, I've got something wrong with it. Let me go ahead and run it and see if it picks up on that error. So I'm going to run dead load. I could delete the modal case, but I'll just leave it as is for right now. Okay, it went ahead and it ran the model for me, even though I have a fundamental error in the model. Does anybody know what that error is?
You're taking full fixity through all your joints. Shouldn't they be pinned?
Okay, that's one error, Carson, not Ben. That is actually an error, but that wouldn't keep SAP from running it. It would SAP is just doing the analysis like it was a frame instead of a truss, but that's good. I appreciate that. And I'll throw you a virtual Smarty. Okay, there is an error that should keep the model from running, but it's not. Nobody? Okay. Let's pause this now. I'm going to go to visual analysis instead, and I'm going to create a similar model in visual analysis. So let me make sure I've got my grid set correctly. Let me put the grid spacing. I'll go, let's see, 12 and 16. I'll go 4 feet for grid spacing like that. Whoops, I typed in 0. How'd that happen? 48 inches. There we go. And so let me put in just 100 divisions in each direction just to make sure I have enough grid to work with. Okay, now let me drag some members. Go to structure. We'll draw main members. I want to go over 1, 2, 3 and up 1, 2, 3, 4. Okay, there's one. Now I can draw this member in. I usually draw my members at either from left to right or from bottom to top. In a diagonal member like that, you have to decide which one you want to be the controlling factor. 2, 3. Yep, there we go. All right, so if I've done this right, this node here should be at x equals 48 feet. It won't let me click on that node for some reason. Let me window over it. There we go. Here we go. So nodes, that node is 48 feet, N5. Okay, good. I need to restrain some nodes. So let me go ahead and make that a dy restraint like that. Is it a pin? Yeah, I'll just make it a pin. How about that? And then over here, I'll make this a pin as well. This one, I don't want any fixity in the X direction. There we go. Let me go ahead and go to my loading tab now. Go to the edit load case. I'll edit the dead load case. And what I'm going to do is take the self weight out. No self weight at all. Then I'm going to select this node and go to apply a nodal load force in the Y direction of -22. Okay. Let me select all the members, and it's assigned them W36 by 231. So we're going to go here. I want to edit the 7 members I selected, not the 5 nodes. And so let me go to database shape. And so here it distinguishes between a pipe and a round HSS. HSS 6 by half. There we go. All right, there. So I think we're at the same place in visual analysis that we were in SAP 2000. Let me go ahead and try and run this model. I don't need to save it before I run it. And I get an error out of visual analysis. And so I got that error. I'm modeling it as a frame. So that's still true, Carson. But the error that I was hinting at in SAP 2000 was enough to actually cause visual analysis to abort the analysis. It was enough to cause it to punt and give me one of those, hey, you're an idiot type of errors. All right, now what's the problem? Anyone? I'm down to, I've lost somebody. Is that true? No, somebody just turned their camera off.
Are you running this as a space frame currently?
That's correct. I'm running it as a space frame. So that model is a plane frame, and there's nothing in the model, in the analysis, to keep that from tipping over. And so it has the ability to move without any stiffness, a rigid body motion, if you will. And so that's what's causing it to crash. So let me go back to my model view here. I'll click out here on nothing. I'll go to project settings, and instead of running it as a space frame, I'll run it as a plane frame. Okay, now if I go back and run it again, now I get the results that we expect. So you can go in and we can look at the results. Let's see, member forces, the results filter. So member results, we could show, let's see, where is it? Axial stress. There it is, FX axial force. So that gives me the axial forces that are in that. Now, yes, it's still modeled as a frame, not a truss, but the forces aren't too far off from what you would get if you did a true truss analysis. All right, everybody with me so far? Okay, let's go back to SAP2000 now. So this damn thing gave me results. Let me go ahead here and plot the results. I'm going to plot the axial force and I want to show values. And so when I do that, it gives me axial forces. Let me close this window, just go to one window. And now you can see, so I've got -13, +13, -13. So those are basically the same results that I got from VisualAnalysis, but this thing shouldn't have run, right? It should have given me an error. So let's go here and show the last run, show analysis messages. And yeah, it doesn't give me any warnings or any errors. It just gives me 2 informational messages. And so let's go over here to analyze. We'll show last run details, and it goes through and let's see. So this thing should have punted on it. It should have said, hey, you guys, you have an error that's incorrect. And in order to correct that, what we should have done is gone to set display options. I can't do it now because the model's locked. Unlock the model. Let me go here to analyze again. One of the steps that we should have done is go to set display options and analyze it as an XY plane frame. There we go. And so now that's kind of scary to me as an academic, because if I have an instability in the model, I want to know about it. I don't want the program to go through and do the analysis and assume that it knows how to make the model stable when it's really not. All right, so the next step is to put pins in. So let's see, let's go back to VisualAnalysis and work there. So all of these members are framed in with rigid connections at the nodes. And we know that if it's going to be modeled as a truss, we want a frictionless pin. So let me try the brute force solution first. I'll just select all of the members. I'll go over to the project manager, select 7 members, and I'll just go in for the releases, and I'll release the strong axis moment at each end of each member. Okay, so that gives me a pin between every member and every node. If I go into the results view, I get another error. It says your model is unstable and cannot be analyzed. And that's true. That's what I would expect. That's actually the program behaving as it should. So if we zoom in on this bottom node, for example, the circles keep scaling, which is almost unfortunate. With all of those, all 4 of those members pinned to that node is free to spin. And so that represents a rigid body motion. It represents a singularity in the program. And so that creates the error. So what we need to do in order to make this a stable truss is we need to go in and make sure that at least one member, and really only one member, is rigidly connected to each one of the nodes. So let me go here to this member. I'm going to go in and remove the releases. So now I have a member rigidly connected to this node, a member rigidly connected to that node. I'll do the same thing for this member here. I'll remove those releases. And then let's see. So I've got everyone except this node here. If I release the first there, so I've got every node has one member that's connected rigidly to it. So if I go to my results view, now it runs fat, dumb, and happy, and everything is great. Now, are we sure that we did it right? Well, there's one way to know for sure. Let me select all of these members. Let me go to a member graph. And if we look at the bending moment for those, the bending moment should be 0. That doesn't work so great with the truss. Let me go up here to the results filter. And for the member, I'll show the moment to M sub Z. And so I got 0 kip feet everywhere. So that means that I did an analysis as a truss and everything was great. Questions? All right. I have a question for you. Can you guys hear the construction equipment in the background? No? All right, that's good. I've got a little Yeti Nano that I'm using here in my office, and the Logitech software does a pretty good job of filtering stuff out, but it's annoying as hell to me. I wouldn't be on campus this week. As you know, I've been teaching from home, but this week we're preparing for an ABET visit over the weekend, and so I'm here to help get things in order for that. And we also have a visiting faculty member on campus from Italy, and Dr. Rosati is traveling this week, so I'm here to kind of get him settled for his stay. I'll probably be teaching from home again next week if everything goes the way I hope it does. Anyways, all right. So let's go to SAP 2000 now. Let me unlock the model so I can add in the releases. And let me try the same thing that I did with VisualAnalysis. We'll try the brute force solution first. I'll select all 7 members. I'll go to assign, frame, and releases partial fixity, and I'll release the major axis moment at both ends. Now, remember, this didn't work in VisualAnalysis. I got an error in VisualAnalysis, and an error that's justified, an error that I should get. If I go in now and run this in SAP 2000, I get results again. At least this time, though, it was nice enough to give me a warning. It said, hey, you're an idiot. I found instabilities in your model. I fixed them. I hope that I did it right. That's basically what that message says. So at least it was nice enough to give me that message. And if we go in and look at the results, then these results are on par with what we would expect. That's basically what we would expect from the analysis. So let's see. Is that a good thing or is it a bad thing that SAP fixed the model for us and gave us results? It's just a preference, I guess. I'm an academic. I'm more conservative. I'm more of a purist, I think. So if my model has an instability, I'd want to know about it, and I want to have to fix it myself. But if the plus side is that SAP gave me results, it guessed at what I wanted and gave me results for that instead. So, the problem is that maybe you have an instability that you don't know about. Maybe there's something that really should be fixed and fixed in a different way than SAP will want to do it. And so that's the problem that I have with this. All right, let me go back to the PDF for a second and see what else is in here that I'm not capturing. There we go, releases. Yeah, so there's the member force diagram. There we go. Yeah, this was all stuff that just talking points. We've talked about some of this already. So all right, how do we model the truss with members that actually have an area of 8 inches squared? So if we want to do that, what we need to do is change the section properties. So we can go in here to assign, frame sections, and we can now define a new section. We can add a new property. And what we can do is go to other and just say a general member. And so now what we do is we go in for the cross-sectional area and we say 8, let's see, type that, yeah, 8 inches, and it converts it to 8 inches squared. So if we take 8 and divide by 12 squared, we get 0.0555 like that. Okay, and then we could go in and put moments of inertia. Shouldn't matter if it's pinned, so we could just leave all that the same. We'll call that 8 inch. Okay, and then I can assign that like such, apply. There you go. Now you have cross-sectional area of 8 inches on all of those members. So if we go in and hit run, it should give us the results. It gave me that warning message again. Done. Let me go here to my displacements, plot displaced shape for dead. I'll hit apply, and then I can right click on this node, and it gives me a translation in the 3 direction of 0.00488 units of feet. Let me change that to inches. It didn't change though. Let's see, I'll go right click on it again. I get 0.0586 inches as my displacement at that node. Okay, let's go back over here. If I click on that node there, For that particular node, I have a displacement in the Y direction of negative 0.5798 inches. So, but this still has the pipe, the 6-inch pipe instead of the 8-inch thing. So let me go back and change the section properties here. So I'll select all of these members. I'll go and make sure I'm modifying the members instead of the nodes. Instead of a database shape, I'll go to a custom blob. They call it a custom blob. I don't know why. And I'll type in 8 inches. I'll leave the other properties the same. Now I go through and do my analysis again. Let me select that one node. And now I get a displacement of 0.0586 inches squared. Okay, so let's see. I get the same results from SAP and VisualAnalysis. All right, so pretty straightforward truss analysis. Any questions? All right, that went a whole lot faster than I thought it would. Let me do a little ad-libbing then. If you guys don't have questions, I want to show you something else. Let me do this. I'm going to create a new model. I'm going to model a beam, and I'm going to just make it a single span beam. And we'll give it a span length of, say, 20 feet. How about that? Okay, let me go with a beam section. I'm going to use a W18 by, let's see, 18 by 44, I think is a section. Let's go 24 by 55. I know that's a section. There we go. Perfect. All right, like that. There's my model. Let me go ahead and I'm going to apply a point load in the middle. So let me go to load patterns. I'll just call it D again. I'll set the self-weight multiplier to 0. I'll modify that, hit OK. Let me go ahead and assign a member load, assign frame load. I want a point load. I want it to be in the global direction. So what's a good load here? Say 20, say 20, I'll spit it out. Yeah. 20 kips. So I'll put the relative distance 0.5. I'll put the magnitude 20 kips. So that means halfway along the length of the member, it's going to put a point load of 20 kips. All right. Now let me save this. Okay, let me run the analysis. Okay, there's my deformed shape. Over here, I can do a moment diagram. We'll go M33, hit apply, and there's my bending moment diagram. Units of kip inches. So there we go, 100 kip feet. So it's 20 foot long, so PL over 4. So 20 times 20 divided is 400, divided by 4 is 100 kip feet. So there's my bending moment diagram. Now, if I right click on that and go into my frame objects, I have a maximum deflection of, let's go here, show max. I get a deflection of 0.1471. Okay, let's shift over here to VisualAnalysis. I'll save this just in case I come back to it in another class or something. I didn't save the other one and I regretted that. Okay, now I'm going to go ahead and create a new model. All right. Let me draw a member. I want it to be 20 feet long. So I'm looking down at the right corner, X equals 20. Good. Now let's see. I need to make that a database shape. I'm going to make it a W24 by 55. Okay, now I'm going to write this down. I get the moment of inertia here. The moment of inertia is 1,350 inches to the fourth. Okay, good. Let me go ahead and give me a dy restraint there. Let me have a dx and dy restraint over here. Let me make this a plane frame model. Let me go ahead and put in a point load. Let's get rid of self weight first. And let's go ahead and apply a load. I want it to be a point load, single point load. I want it to be, it could either be shear Y or it could be force in the Y direction. I'll call it force in the Y direction. And we'll take it minus 20 kips, offset at 10 feet. Okay, good. Let's go ahead and do the analysis. Right. So if we click on that beam, the maximum displacement I get is 1471. What did I get over here? I got 1471. Okay. All right. Interesting. So simple beam model. All right. We covered a lot of ground. I wasn't expecting to get this far. I should have posted another handout in case, yeah, the last couple of classes I posted material that we didn't get to. In this class, I should have done the same thing, but I didn't. Yeah, I could post a handout and then let you guys download it and we could go through some new stuff. But I think at this point, let's go ahead and just knock off and end class early today. And then we'll regroup next time. And next time we'll start talking a little bit about matrix operations. So, all right. Any questions before we conclude? All right, I don't see anything in the chat. I don't see anybody talking. So, all right, yep, we'll call it a wrap here, and then I'll hang around for a few minutes if you have any questions. Otherwise, I'll see you guys again on Tuesday at 12:30.
Did those drawings work for you? Did you want any?
I went to lunch right after I